the title of my talk is Kubernetes hardware hacks. So what we're going to do during this talk is we're going to actually not talk about hardware too much. It's in the title, but and I'm going to be doing some stuff with hardware. But we're going to actually explore the Kubernetes API and what you can do with the API, what sort of things are available, and we're going to explore it through using it with some actual hardware. So to kind of introduce myself, this is a red hat, but I actually work at Google. And a quick, who do I support for the U.S. Presidential election? That's a joke. But so I I work at Google as a developer advocate in Tokyo, Japan. So I cover mostly APAC area, but I do travel quite a lot to the U.S. This is actually my first time in this role doing a trip to Europe. But you can kind of follow me on Twitter at Ian M. Lewis. And just as a fair warning, I do speak Japanese a little bit, and I will tweet in Japanese every once in a while. So, and this is actually a little reference to to kind of a famous Linus Torvalds T-shirt. It says like, "I can do Linux a little." You know, it's a little bit of an understatement for Linus Torvalds, but not quite as much of an understatement for me. So, so what do we actually think of when we think about a dashboard? Something that tells you a lot about the sort of important information that you want to see for any type of thing. Software people, which I think most of us are, kind of think about dashboards as something like this, right? Something that will tell us information, like maybe it's how much money you're making today. Maybe it's something like how many requests per second are coming into your app. Maybe it's the buzzwords that are popular today. But really, this is kind of a representation of something that's physical, right? So something like a car dashboard. So a car dashboard tells you a lot of information about what's going on right now, the things that you really care about right now. So when you're driving a car, you want to actually know like how fast you're going, right? That's pretty important. Also, how much gas you have in the car. You don't want to CO2 emissions. Yes, some of them actually have those nowadays, but you don't want to break down on the highway. So I think that the gas is a little bit more important. With the VW. Yeah. So this is actually a pretty old one. I had to find a Creative Commons image, so I couldn't find one that had the CO2 emissions in it. But some can actually get pretty complicated, right? Like if you need to know a lot of information, dashboards can get pretty complicated. This is an F-104 Starfighter. This is also a pretty old, an old jet. But these type of dashboards also exist, right? But so they can get pretty complicated, and these are actually really, really useful types of dashboards. But I was, when I started out doing this talk, I had something more along the lines of this in mind. I wanted to see something that was in front of me that I could use to actually, interact with the cluster and know what's actually kind of going on in it, and get like a good idea and maybe cause some mayhem, that sort of thing. So it was actually important for me to kind of play around with the Kubernetes and get information from it. But so how would you actually do something like that? Like how would you actually build a dashboard or build something that would show you what's going on in your cluster? So to do that, I'm going to step back a little bit, talk a little bit about the kind of high-level overview of Kubernetes and how you actually interact with it. So Kubernetes, has a master, as many of you probably know, and has nodes that actually run the containers. And there's a lot of kind of moving parts in it. So things like XZD to store state and the API server that you interact with and the scheduler and things like that. But from the standpoint of a dashboard or of an API consumer, you really only need to think about the API as an interface to your cluster. You don't really need to know necessarily about all of the internal workings. So you can actually just interface with the API, and then everything after that, you can just assume that Kubernetes is going to do what you want for you. And in our case, so like the client is actually not going to be a person necessarily, but it'll be a dashboard or some switches or something like that. So if you I need to switch out for a second and actually start that proxy. But so the API is available. How many of you have actually played with the API? Okay, so a few of you. So the API is a RESTful JSON API that is built into the master, and it has a Swagger spec. So if you're familiar with Swagger, it's a way of generating API documentation, and if you have a proper spec, you can actually generate some clients and that sort of thing. But that also allows us to have some documentation. So here's the and if you actually connect to your master at / Swagger spec, you can actually look at the spec for your API server. So here you can kind of look at things like which API endpoints are available in the master, and so it's a RESTful JSON API. So most of the endpoints are representations or are for resources and in RESTful parlance, and these correspond to objects in Kubernetes. So Kubernetes is kind of based on objects. So when you actually do things like get pods, like things like pods and nodes and replication controllers are objects. And so when you actually look at the API, each of those endpoints are actually something that represents those types of objects. So you can see things like namespaces, endpoints, pods, and the like. So here, if you actually click on one of these endpoints, you can kind of go and see the information about what sort of response you're going to get back and what sort of parameters that the API expects. So here you can see this is the endpoint for getting a list of pods. So this is going to, if you give it the right namespace, it will give you all of the pods in that namespace. And you can give it some parameters down here, like a label selector or a field selector, to kind of limit the pods that come back. So you'll get back this kind of list. And the API, pretty much all of the responses will give you something like this. So it'll give you an actual kind and an API version and some other metadata along with it. But the thing that you really care about is in this items part. And so in here, it's actually going to have the data about the pods that are running in that particular namespace. So things like the names of the pods, the spec that you create, like in the YAML files, gets shown here. So pretty much everything you'd ever want to know about a particular pod you can actually get from the API here. So things like the persistent volume claims, as well as things like which containers are actually running in the pod and things like that. So that's pretty cool. Let's go back. So as I said, the API is based on objects and around Kubernetes. And so in Kubernetes, and it's actually the most RESTful API I've actually ever seen. It's pretty much all of the endpoints are just for objects or for resources. So if ever you want to see a really great RESTful API, then the Kubernetes API is really good. There are no endpoints for things like scale my replication controller or scale my service. Those type of things, those type of verbs are not present in the API. Generally, what happens is you will either create or update using the normal put and post type of HTTP methods. And but when you actually want to do actions, it's not necessarily intuitive. So say if you want to update or scale a replication controller, you want to you'll actually just change the replication controller or the number of replicas on a replication controller. So you either do a put to update it, or you'll do like a patch method, or use the patch method to patch just the number of replication controllers on the, or the number of replicas on the replication controller. And then Kubernetes uses kind of a control loop for these types of objects. And this is like kind of an observe, diff, and act type of control loop. And most of the objects have something similar to this. Or they have some sort of control loop, but the replication controllers are the prototypical example. So it would the control loop will observe the current state, and then actually diff to the desired state. And so if you had a replication controller that you were gonna scale from 5 pods to 7 pods, it would observe that the current state is 5, diff with the desired state of 7. Figure out that it needs 2 new pods, and then in the act step, it'll actually go off and schedule those new pods. So you can kind of think of the API as being something that will kind of allow you to update a particular object, and then the control loop will kind of do everything asynchronously for you in the background in order to bring the current state into the desired state. And so that's kind of how the whole declarative kind of configuration happens, and so that's very it's very good for that sort of configuration or declarative configuration style applications or style system. So next, I kind of want to talk about some clients. So the situation for clients is actually pretty bad still. It's still very early for building very robust clients for Kubernetes, but I think most people are familiar with the command line interface, the kubectl, and kubectl is actually something that will go and will actually interact on or use the API on our behalf when you actually run the kubectl commands. And then for kind of programmatic clients, there's the official Go client, and the official Go client is actually built into Kubernetes. There's a library or a package inside of Kubernetes that's built for the client, but right now it's got a huge dependency tree. So if you actually try to use it, you'll have to import almost all of Kubernetes into your project, and so like that's a little bit that's not quite the best outcome, but it's the way things are currently. And there's some work going on to actually reduce the number of dependencies that the client has so that it can be imported much easier into other projects. But there's some other ones that are actually pretty decent, like the Fabric 8 OSGI client. This is a Java client for Kubernetes, as well as a recent one, which is PyCube. This is something that was built by the folks at Gondor. So this is a Python client that can do all kinds of cool stuff, like it can actually do the authentication and things like that for you as well. And so Kubernetes in the documentation has a list of client libraries that they kind of know about and are pretty decent. So if you're a kind of a Ruby person or a Perl person or something, then you can kind of check this out. There's just a document markdown file that has all the list of a list of the client libraries you can play with. So next, I want to talk about kubectl. So kubectl is I mentioned something that will interact with the API on your behalf, but I don't think that that very many people have actually looked at what kubectl actually does. So one of the things that I'm going to actually sit down here, but one of the things that you can do with kubectl is kind of see what the API or what API calls it actually makes when you run commands. So that's what I'm going to do here. One of the things that's also really cool about kubectl is that in order to interact with the API, you can run the kubectl proxy command, and this will actually set up a local proxy on your on localhost on a particular port that is unauthenticated. It'll basically wrap the API for you, so that when you make request to the local proxy, it'll wrap that request and do the authentication for you. So it makes it really easy to actually integrate or interact with the server. And actually, on that note, I'm going to, before I do that, I'm going to see how to actually use that. So you can actually do some pretty cool curl with to check out the local proxy or to play with the API. So the API, let's see, version 1, namespaces, default, pods. So you do something like that, you can actually like just hit the API and get back the JSON for a particular cluster. So in this case, I have a guestbook service running. So if I do kubecontrol get pods, I can see that I have like this kind of PHP front end and a Redis master and slave running in this cluster. And so you can do things like if you're familiar with the JQ command, you can do some queries of the actual JSON. And actually, let me. I have a cheat sheet here. No. So no judging. So here's like a cool query that can actually give you a much simpler piece of JavaScript to show just the name of the pod and the status of the pod. So you can do like kind of things like this and kind of play with the API and find out the kind of interesting information or interesting bits out of the API that you care about. So that's pods. So you can actually see the pods and what their state is. If you go back here, I have like one for replication controllers. So you could say like get the name of the replication controllers and how many replicas it has and are running. And so that's curl. But kubecontrol actually will do API requests for you as well. So what I'm going to do now is actually I'm going to set up this is a program that is a local HTTP reverse proxy, but it's going to actually log all the requests for me that are happening on the local host. And then that's going to proxy to the Coop proxy for me. And so if I say like get pods, and then I give it the server for my my reverse proxy, I'll get back the same number of pods here, but I can actually go over here to my reverse proxy and see the API calls that kubecontrol actually made. So you can actually notice that it did the thing that you expect. It went into the default namespace and got the pods, but it also made a request over here to this API thing, which is kind of maybe unexpected. So if you're somebody that knows a lot about the API, you'll know that this endpoint is actually something that will give you the versions of the API that the server supports. So the server will actually give you back a little bit of information. In this case, it only supports version 1, but you can imagine that when version 2 of the API comes out, you'll get a list that says that the server supports version 1 as well as version 2. And then the kubecontrol client can then act accordingly based on which versions are actually supported. So that's kind of cool. So what other types of things can you actually do? So say like if you do something like a label, use the kubecontrol label command. So something like this one. So here I'm going to like add a label foo to my front end replication controller. Actually, this is 3. And so if you run this, you can kind of see what the label command does. So in this case, it's actually going and getting that particular replication controller, and then and then doing a put. So it's actually doing a full get and then doing a full put of it. It's actually not doing a patch request, which is kind of interesting as well. So that's kind of cool. So like there's like a number of things that KubeControl does, and it might not always be completely expected or expected how it actually interacts with the API, but it's kind of interesting to see what sort of things or how a KubeControl command might actually translate into an API call. So that's something, or you can get kind of different, or a good, you can get a good idea of how you might implement a particular type of action that you want to do on your cluster by looking at what the KubeControl command does. So going back, so we looked at pods and we looked at labels. So one of the things that KubeControl does is rolling updates. Now, my cluster is not in quite the right state for my demo. So I'm going to rebuild it. But then, so what I'm going to do is I'm actually going to do a rolling update and kind of see what sort of requests that it's actually doing. And rolling update is one of those things that's kind of going to become pretty kind of deprecated because of the new deployments. But we can kind of get a good idea of what the what API calls it's actually making, and then we'll probably figure out why it's deprecated, or get a good idea why it's deprecated. Okay, so now we've done that. So here's my rolling update command. So as I'm doing this rolling update, I can go over here and see the sorts of requests that it's actually making. So rolling update, as we all know, like will create a new replication controller for the and for our service, and then scale down the old replication controller and scale up the new replication controller, right? So what we'll notice here is that as it's kind of going through and doing this, it's actually doing a lot of these kind of get requests to the replication controller to kind of understand the current state, or to know the current state as it's continuing on here. And it's doing all of this stuff from the client side. So things like, so if, say, like your Wi-Fi goes out or something weird happens, like in the middle of this, the server doesn't really understand things like rolling updates. So you'd end up leaving your cluster in kind of a weird state. And so that's kind of one of the reasons why you might not want to do a rolling update by KubeControl, but actually use the deployments feature. So it's kind of interesting as it's going through. It's kind of like updating the replication controller to add the new or to change the number of replicas as it's doing the rolling update, and then finally it actually deletes the replication controller that was updated, or the old replication controller. And then after it's done that, it checks to make sure that the new replication controller is in the right state before actually finishing. Okay, so that's interesting. So going back to the slides here. But probably that's not exactly what you guys came here to see. Like, I think a number of you probably came by the booth yesterday and saw the demo that I was doing. So next I want to talk about the dashboard that I've built to using the API to actually kind of visualize the state of a cluster. So just to kind of show it first. So what I've got here is I've got a kind of, this is a document camera that's showing these two. These are MIDI controllers, and it's a little bit dark, and you'll see a little in a second why that is, because these buttons will actually light up. But these are MIDI controllers usually used for music, and so like you might have some set sounds that you've registered for each of these buttons, as well as these kind of faders and sliders for doing mixing. But what I'm going to use it for is actually these are I'm going to use MIDI to talk to these and interact with these, but I'm going to actually get the information that I'm going to show here from the Kubernetes API. So if I actually scale these up, you can kind of see how the cluster is working. And so this is kind of a representation of the cluster. It's kind of a little bit difficult to see, but you can at least see the parts that are lit up there. So this is an 8-node cluster, and each one of these columns here actually represents a node in the cluster. And so each one of these nodes has some pods scheduled on it. So each one of these lit up buttons represents a pod. And these pods are different colors because these pods at the bottom, which are kind of teal colored or green colored, these are one replication controller, and then I have a second replication controller running. And so these are the pods for each of those replication controllers. And what's actually running in these pods is this bottom one is a set of Nginx HTTP servers, and then these other blue ones are applications that are generating load HTTP requests, about 1,000 requests per pod to the Nginx server. So it's all internal to the cluster. But over here, we can actually see like kind of a visualization of the requests per second in real time that are going on in the cluster, as well as the latency. So what I can do is I can now use these sliders over here on the right to actually scale up and down each of these replication controllers. And what that actually does is it takes the inputs via MIDI and then will translate those into API calls that actually get sent to the API. And so, and each one of these, as I scale it, will actually show the pods that are in a particular state in a slightly different color. So here the red ones are terminating, and if I scale up, you can see that the ones in yellow here are pending as they're being started. So the ones that are in their final color, or these blue colors, are actually running pods. So then you can see that, like, as I scale up the load generating servers, or the load generating pods, that on the right, it should in a second or two actually show a higher request per second. Or it doesn't. Oh, there it goes. So it's taking a little bit of time because of the network, I suppose. But here, it'll actually start generating. Here it's got, let's see, 42 load bots. So it should be doing about 42,000 requests per second. So we can kind of see that it is. But we can see down here that the average request latency is actually jumping up pretty high. So my Nginx servers are not actually handling the load properly. So I can go up here and scale those up as well. I'm like filling up my cluster. And then hopefully after a few seconds, the latency will become a little bit more manageable. So from this, you can kind of get an idea of like what kind of what's going on in the cluster, and what pods are running where, and that sort of thing. I also added a little fun feature that if you press these buttons, it'll actually delete a pod. So you can kind of play whack-a-mole a little bit here. So that's like another one of those fun features. You don't want to like lean your elbow on this thing. So if you do that, you can actually see and you have enough. You don't have a whole lot of Nginx servers, then you can actually see that reflected in the latency, like when you start killing pods and things like that. So this is kind of cool. Like, so let's go back and kind of talk about how this is implemented. So this is a little bit over-engineered, which we like to do at Google. So we have 4 different apps, and so just to kind of like run the entire circle here, from the API, this publisher app, which is written in Python, will actually get the pods that are running in the cluster from the API, and then publish that. It kind of translates that into the data that you want to show on the Launchpad, and then post that to a pub sub channel. And then this other Launchpad app, which is written in Go, will take that data and then write it to MIDI for my particular hardware. And then on the other side, my launch control, which has the sliders and everything on it, if you slide there, those MIDI events get picked up by the launch control app, which is also written in Go, and post to a pub sub channel. And then the subscriber app, which is written in Python, will take that data from the pub sub channel and actually update the replication controller in order to scale the app. And this is a little bit, we have this pub sub channel in the middle here, and you might wonder why I did that. But it makes a good hook point for actually adding other types of visualizations and hardware to my dashboard. So I might have not just this Launchpad, but actually have some other hardware that's running on my dashboard or on my desk that I might want to show. So this is something that I hope to expand in the future, because this doesn't quite make a full 180 around me. So I need to add some more hardware to it. So, kind of to continue, this is actually something I want to get to at the end, but let's actually look at how I implemented this. So let's actually look at some code here. So first, I want to start looking at the publisher, and this is the app that's getting the pods and publishing to PubSub. So this is an app that's written in Python. And then we can kind of see here that, let's actually make this a little bit bigger, if I can. Nope. Make it super big. Yeah, so here we can see that like I have a loop here that's basically looping over and over again. And so basically every second I'm going to go out and get the nodes that are running in my cluster. So the nodes, so I might have nodes that are in my cluster, but actually don't have any pods running on it. So I want to actually be able to get all of the nodes that are running in the cluster. So that's why I actually do a request to get the nodes. But then after I've got a list of the nodes down here, I go and get a list of the pods that are running in the cluster. And here I'm just getting the default namespace, mostly to make it a little bit easier to show. And then continuing on, I take those pods and then I map them based on this node name to the node that it's running on, so that I can put each pod in the right column. And then enumerating over the nodes, I give it a color based on what status it's in. So based on whether it's pending or it's running or it's terminating. And so here I also, and based on a particular color label, I determine which color it's going to be when it's running. So if that particular pod has a label that's or a color label, I can take that color and use that to show it on the Launchpad, which is kind of cool because you can then do kind of rolling update style things to show which pods are in a particular replication controller are being updated, or which replication controller is the new one and which one's the old one, and that sort of thing. And then at the end, I just check to see if the grid has changed and then publish that to PubSub. So let's continue on. And if I look at the actual Launchpad, so this is actually a Go app. this application will get the data from PubSub. Let's go to that particular part. So this is actually not the right part. This is it. So here I'm going to pull the data from PubSub that was published by the Python app. And then down here at the bottom, I'm going to get the message, parse out the JSON, and then here I'm going to basically just reset the pad and then light the particular, using the X and Y, and then these are RGB values. I'm going to light the particular the particular button on the launch pad. And so this pad object is part of a library that I built for the Launchpad that uses another MIDI library. And one of the things that's interesting about this particular guy is that it allows RGB values for the color of the button, so you can actually have quite a lot of different colors on the Launchpad. So let's go to look at the launch control. So the launch control is the one with the sliders on it. So if we go down here, we can look at this is a for loop that's kind of running, checking for new events coming from the launch pad. So if you actually make a slide, you actually slide up and down on the launch pad, it will get the events. And then this is a little bit of a cool thing to check to make sure that if no event has happened for half a second, then it actually publishes to PubSub, because as you slide up and down, it will actually create multiple events, or it will actually trigger multiple times as you're going up. But this basically means that you need to, as soon as the slider has stopped for 500 milliseconds, then you can actually publish to PubSub. And then this takes the JSON object, or creates a JSON object, which then it publishes to PubSub. And that particular event will just have a value in it of where the slider is. And then that particular PubSub object gets picked up by a subscriber Python app, which then updates the API. So here, I'm pulling the messages from PubSub, and then deep parsing out the JSON and getting that particular event. I'm dividing it by 3 because the slider would end up giving me a value that's way too high, so I couldn't just use that for the number of replicas. But I'm just dividing it by 3 and then using that to scale the app. And then here I'm actually just doing a regular old patch request and sending that to the server, or to the API server. So here, all I'm doing is sending a patch request with the correct content type, and just changing the number of replicas for that replication controller. So, in some ways, to wrap up here, I wanted to talk about why I did this and why I think that the API is important. By deploying things in Kubernetes, Kubernetes actually will help you with standardizing deployments. So things like deploying apps and getting information about how many processes are running in your cluster, what the state of those applications are, how much CPU and memory they're using, those type of things are all things that Kubernetes gives you really easily through the API. And those are things that you can use to then build dashboards and other types of applications that'll help you to solve problems, to help to understand what's going on in your cluster. So a really good example of doing something that would using the Kubernetes API would be to build things like dashboards, obviously, but other things like doing more continuous integration or continuous deployment. So you can imagine maybe having, when you update your application, that it gets built into a Docker image, and then when that Docker image is available, that you can then use the Kubernetes API to update a deployment in your staging environment for testing, for instance, or those types of things. Obviously, you could also build dashboards. The dashboard that they just talked about a few minutes ago is also a Kubernetes client or an API client. So that gives you a lot of information about what's running in the cluster, what's there, how many pods are running, that sort of thing. Another great one is the Kubedash project. Kubedash is a client that uses the Heapster API to show the CPU utilization of a particular app or of a particular service, as well as the utilization of particular nodes or by namespace. So those type of things are also things that you could do with the API that would really kind of help you to understand what's going on. And so right now, Kubernetes, there's still not a lot of apps that utilize the API and all of the information that the API gives you, and all of the types of things that you can do with the API, like scaling or doing updating deployments or those types of things. And so what I really want is for people to go out and play with the API and get an idea of what kind of applications you can build using the API to kind of help you make your life and hopefully other people's lives easier. Kubernetes is an open source project, so that means that it lives in this open source ecosystem where you can build on top of it, of that API, and build open source projects that other people can use. So having a much better and larger ecosystem is going to be better for everybody. So I think that using the API and making and understanding the API, especially for us who are using Kubernetes or are early adopters of Kubernetes, is really important to help get new users to come and start using Kubernetes. So that's all I had. I hope that was helpful getting an understanding of the API, and hopefully you got you're a little bit more motivated to sort of play with the API, and hopefully that will also inspire you to kind of make some apps on top of the API and make everybody's life easier and grow the Kubernetes ecosystem. Thanks a lot.
So before we start the Q&A, I think we finished a little bit early, but I planned ahead. So we will do an impromptu talk about the new Kubernetes website that just launched, and the person leading the charge on that will be here to give a short talk on that. But before we do that, you can go ahead and get mic'd up. We're going to go ahead and do Q&A. So any questions for Ian?
Anything at all. 0, that's crazy. Somebody's got to have a question.
Where? You have to jump up and down on your chair. It was in the code of conduct. Read it.
Hi, thanks for the talk. So, just curious, how much do these toy costs?
These two toys?
Yeah.
They're about $100 a piece.
Okay, dollars.
Oh yeah, we Americans.
Yeah.
Not everyone uses dollars. Any other questions?
You should buy these and then, get your boss to pay for them.
Hello. Are you using these toys in production?
Yeah, I wish I could, but my cluster's way bigger than 8 nodes, man. Sorry.
No, we actually manage Gmail with those.
Yeah. There's actually, what you can do is you can actually buy 50 of these, and then, you can just line them up in case you have more than 8 nodes cluster.
See, Ian's a really nice guy, so he had this thing set up downstairs earlier, maybe yesterday, and I'm just walking up and I'm twisting knobs and he's just twisting them back. I'm pushing buttons, he's pushing it back. I'm like, dude, what are you doing? He's like, you're screwing up the damn cluster, man.
I'm a little bit obsessive compulsive, you know, like you're like messing up my
But
stuff.
it would help if you tell people I'm taking Gmail down every once in a while. So, all right, thank you, Ian.